It is now broadcasting. Should this be recording already?
I would not record. Okay. All right, David, I think we're ready to go.
I agree. All right. Welcome back, everybody, for our first afternoon session here. I'm actually going to turn this over to Sharona right away for a couple of reminders on things.
Okay, you're going to hear this at every webinar we're going to do because it does need to be part of the recording. So we are recording this webinar. We plan to post recordings and slides so you can view them later. We retain the right to rebroadcast and distribute the recording. And to clarify, I was asked, can people screenshot? Absolutely. We just are making sure that we have the right to rebroadcast and distribute the recording. And you're agreeing by participating that your contributions become a part of the recording. That includes any video of the panelists, audio chat, and Q&A. There is a much more robust Q&A portion of this particular one. So just a quick reminder, you're going to be using 3 different things to look at today. You're going to be using the chat to have a discussion among the attendees. So please make sure that you have switched your chat to say all panelists and attendees, because we have a couple of people just using panelists. That makes for some very strange conversations. We also have a Q&A for larger questions. And also when we get to the Q&A portion, we will be using the raise your hand button to allow you to unmute and ask your question live. So those are the 3 ways we can do that. Do we also have the sponsorship slide here, David, or no?
I think that I may have failed to add that. I'm sorry.
Okay. So I just want to add one more comment about College Bridge. We are being sponsored by College Bridge, which is a nonprofit that looks to align the pathways to math success from K-12 to college. And one of the things that we're going to be announcing a little bit later in this conference is several of us on the panel are going to be running some How Do I Teach Math Online courses starting in a couple of weeks, and they are not free, unfortunately. But if you come to the Mastery Grading conference, you're going to get a 10% discount. It is a 4-course sequence where we're going to try to dive real deep. And of course, since many of us are teaching it, it'll be heavily consistent with Mastery Grading principles. So we'll be announcing that over the course of the conference. On to you, David.
All right. So this is a 2-hour session. We're doing 2 things back to back without a break in them. So prepare yourself. And I would now like to introduce myself. So I'm going to start our session off still wearing the same shirt. And here's sort of the big picture of what this part of the session is going to be. In the first session and the talk, we talked a lot about the philosophy of mastery grading, sort of what's in our minds. Why do we do things this way? What's the point? And that's really high level, right? That's the 10,000-foot view of what we're doing and why. Right now, I'm going to give you one particular example of what the structure of an entire mastery graded course might look like. It's an intentionally simple example, and it is, as I mentioned in the first session, it's not going to be the only way to do things. This is just one example so that you have a sense of what that might look like for you. And if this doesn't sound what I described as something that you might want to use, then don't worry about it. I'm not claiming this is the one and only approach. After I do that, we're going to see some examples of what I call the local decisions of mastery grading. So what does it look like when you're actually grading something? What are the decisions you make, and how would that inform what you might have chosen to do in your course? So we're trying to give you a bunch of different levels here, right? A bunch of different layers of big picture view, class level, global view, local decision view for mastery grading to get a sense of all of this. And yes, this is very mathy, thank you. All right, so I'm going to begin with this example. This example comes from a particular kind of mastery grading we call mastery-based testing. I'm going to call it MBT a lot. This was originally inspired by George McNulty, who's at University of South Carolina. So I want to be sure to give credit where credit is due. And many people I know who are here use this particular approach. One thing that is particularly nice about this style of mastery grading is it's relatively easy to put it into a class that you already have, that already exists, and fit it within a structure of points and percentages that you might be required to use in a coordinated course or from department or university requirements. So here's, again, just an overview of what a class like this, of what the whole course might look like. You could choose 16 objectives. The objectives are really broad. They are types of problems that anyone passing Calculus 1 in this example should be able to do, right? Very big picture things like calculate limits or work with limits computationally, symbolically, and graphically might be an example of how broad we're talking about here. So you have these objectives. You teach some topics, you do whatever class activities you might normally do, and after you've addressed about 4 of those objectives through your class time, you have your first exam. And in that exam, you address 4 objectives. The way I like to think of this is one page, one themed page per objective, but there might be more than one problem on that page that covers the variety of things that that objective needs to address. Students earn only a mark of demonstrated mastery, you're progressing, or not yet on each of those objectives for the totality of their work. Did they demonstrate this proficiency you need overall? Continue class, cover about 4 more objectives worth of materials, have another exam. In that exam, there's 4 new problems or 4 new pages addressing the 4 new objectives. And then there's also 4 pages recovering the old objectives, so readdressing them. And those who've already completed those successfully on the first exam don't need to touch the new ones in this particular way that I'm describing it. But some people may need to again. And then there are, again, these 4 new ones. Continue, right? Wash, rinse, repeat. So 4 new objectives in class time, another exam addressing those 4 new ones, and the 8 we've already seen. So this is the reassessment component where you're having an opportunity to reattempt problems of a type you've already seen. Do that once more so that we've gotten up to 16 total. And then the final exam in this setup could be one last opportunity to demonstrate mastery of any objective, or it could be something like one chance to recertify on some objectives. Maybe you've marked a few of them as core or essential and students have to demonstrate mastery a second time. So the overall idea here is that the grading is very quick. Just you met the bar that I've set, you're making it there, but it doesn't count or not yet. And that only the best mark or maybe only the most recent mark on each of these matters. So this is, again, the big picture idea that I'm just trying to give you here. How do you actually get a grade out of this? How do you incorporate this into your overall course grade? There's a couple different ways. Here's one. This is why I say that this fits well into an existing class structure. You could just calculate the number of objectives that a student eventually earned mastery of and divide by the total number of objectives, and that's your percentage for the exam grade in a course. And so if your exam counts for a certain percent of your overall grade, that's how you calculate what that value for the exam grade is. This is why it could fit into a traditional points and percentages system. And I see a question that has been answered there, but yes, this is, you might only need to demonstrate mastery of an objective once in this, but you could also add in twists like requiring students to demonstrate mastery twice or to do it again on the final for certain very central objectives. But this is not the only way that you could address how this turns into a grade. This is what I'd call sort of a way to fit this into a required syllabus structure where you have to have a certain percentage for your exams. Another option could be something that I know many people do on the right here, where we have a table. There's 3 grade categories: exams, but then also maybe you have online homework and maybe you have portfolio problems, right? So some writing related problems. And the rows correspond to letter grades. You must do the things listed in the rows in order to earn that letter grade. So to earn a B, for example, you have to demonstrate mastery of 14 of the 16 objectives. Earn 95% or above on 8 of the 10 online homeworks, and complete 3 of the portfolio problems. So maybe these are more detailed writing problems. This would be another way for you to spell out exactly what it means to earn a B, for example, in a class like this. So once again, this is not the only way you could do this, but this is an example of what it might look like. And it's another thing that you have a lot of control over. If you see something you don't like in this, you could change that a little bit. If you feel like this structure doesn't work for you in your class, there's a lot of other possibilities. But I want you to have in your mind, if you need to go to a concrete idea of what type of setting might we be doing the things that we're about to talk about in, this is an example of what that class could be. All right. What I'm going to do next is I'm going to introduce the first of our speakers who are going to then look at this local view of what might it actually look like to grade a problem in this type of setting. And so I'm going to introduce Amanda Harshey, and she's going to say a little bit about herself and then let me know when she wants to show you some sample problems.
Okay.
Did I just steal your thunder, Amanda?
No,
Okay.
not at all. So I'm Amanda Harshey. I teach at Lewis University. It's a regional Catholic liberal arts school in the Chicago suburbs. We have about 6,500 students, and a lot of our students are commuters. So I've been using mastery-based testing, a method that's very similar to what David just introduced. So that works really well. Like, it's a very simple, like, mastery, not mastered way of grading. So I've been doing that for 7 years, and I've used it in real analysis, linear algebra, calculus 3, calculus 2, and graph theory. I also do research comparing mastery-based testing with traditional assessments in Calculus 2. And I've also collected data on anxiety levels and growth mindset of students in mastery-based testing courses. I know people were talking about grade distributions earlier, and I would echo that I do kind of get a little bit of a bimodal grade distribution. But most students seem to prefer, and I think it really helps the hardworking B student get A's. So when I do mastery-based testing, I only use it for the exam portion of their grade. I use traditional grading for homework, quizzes, oral exams, labs, and other aspects. I usually only have 12 to 18 concepts and 3 to 4 exams and 3 to 4 retesting weeks in which students can retest any past concept once during that week. I use core concepts in Calculus 2, which is similar to what David was kind of mentioning earlier. And I use a 3-tiered grading scale, mastery, journeyman, and novice, but I like the term progressing better.
Are you there, Amanda?
Looks like she's
We might have
frozen.
a freeze. Yep. All right.
You want to skip to my slides and let her do it when she gets back?
Let's do that. So I would next like to introduce Sharona Krinsky.
Hi, everyone. So once again, I'm Sharona Krinsky. I work at California State University, Los Angeles. We're part of the Cal State system. We have about 23,000 students on campus, mostly commuter. And we are primarily we're what's called a Hispanic serving institution. Over 80% of our students are Hispanic, mostly coming from the East LA area. So they do tend to come from very traditionally underserved communities. I started doing about mastery-based grading about 3 years ago. I kind of jumped off the deep end in one semester and converted 3 different preps at the same time. And I'll talk about that a little bit later. Go ahead, David. I wanted to start by sharing my rubric that I'm probably going to move away from, but I was using a 4-level rubric. So my 4 levels were exceeding expectations or exceeding mastery. The second level was mastery. The third level was near mastery, and the 4th level was well below mastery. I did have a 0. That was for essentially tracking of blanks and things like that. I don't really use that so much anymore. The 4 levels I have found are very, very useful if you're working with other instructors. So one of the challenges that you often face when introducing other people to mastery grading is a perception that mastery is perfection. And a lot of people who are maybe not quite as bought in have real trouble giving mastery without perfection unless there is a level above basic mastery. So for me right now, the 3 level is mastery. So the difference between 3 and 4 is just for feedback to the student. And the difference between 2 and 1 is for feedback to the student. This also depends on what type of mastery you're doing. I used to do something called decaying average, where the numbers came into play. I found the students had so much trouble understanding it that I got rid of it and went to 2 times mastery, and either a 3 or a 4 is good for that. Go ahead, David. So this is where we get down to the individual quiz levels. So this is a particular problem that I give. And what I'm going to do is I'm going to go through the problem and make sure that you guys have the correct work. And then we're going to check student 1, who is the one with the 6 answers, and student 2 is the one with the 3 answers. And we're going to check those for mastery. So the standard is Introduction to Sequences and Series. I typically do this in Calculus 2. But the mathematics is certainly available to an Algebra 2 instructor if they're introducing sequences, because this is a sequences problem. You notice the standard has a lot of things in it, and this particular problem is not necessarily looking at these particular parts of the standard, which is why I have since then rewritten the standard. But the problem is to describe the first 4 terms of the following sequence. The correct 4 terms would be 6, 11, 34, and 67. So you have 2 different students. Student 1 is on the left. So if we could run a poll and tell me if you think that student 1 has mastered an introduction to sequences and series, do they understand what they're doing? Yes or no? We'll give that about a minute to vote. Or Bosley, if you see that we end up getting super close to 100%, we can always cut it early. Yeah, unfortunately, once we run the, so there is, the student work is a little bit blocked by the polling session. I can say that the student, left student there, A sub 2 was 11. The one on the far left, it went A sub 2, 11, A sub 3, 21, A sub 4, 41. And then they put 3 more answers, A sub 2, 19, A sub 3, 58, and A sub 4, 175. So that's all one student in that big box.
All right, Sharona, we are a little bit over a minute. We've got about 239, but still growing on the vote.
Okay, we can give it some more time. So we had a suggestion. If you take your screen share out of full screen, if you're on the Zoom, then you can either move the polling around, or you can move the screen around so that you can see it a little better.
All right, we're at almost 75%, but the votes are slowing down. So I will end it in about 5 seconds if anyone else wants to vote.
Okay, and Bosley, can you share the results? Okay, so 94% of people said no. Okay, so let's look at this. Now let's look at, let's close that, and in just a moment we'll reopen the poll. So then we have student 2, which is the box on the right. And take a moment to look at that, and then we'll reopen the poll. Did this student show mastery? Okay, let's go ahead and open that. Yep, and let's vote on that one. So we're learning some things about taking the webinars on the iPad. It definitely has less controls.
Okay, so these votes are coming in much faster. We're at 80%. I'll shut it off in about 5 seconds.
Okay, so we have about 50-50 on this one. So I want to unpack how I look at these two students. So when I'm looking at it, and again, unfortunately, this particular sample no longer fits the standard, but if I just look at it from the perspective of, do they understand how to describe the first 4 terms of the sequence? So the first issue is the student on the left gave me 6 terms. So that's already showing a lack of connection to the problem. And they only got 1 out of the 6, quote unquote, right, because they didn't know what to do with the piecewise defined sequence. So the question becomes, am I testing piecewise definition? Am I testing sequences? Like what is the thing that's going on there on the left? And what I tend to find is that they're really having trouble with the whole concept of what is a sequence, because they're not actually listing the terms. The student on the right made a arithmetic error. So they made actually 2 errors. The first thing they did is they got A2 correct, but then when they went to A3, it should have been 3 times 11 plus 1 instead of 3 times 11 minus 1. So they typoed the problem. And then on top of that, they didn't do the arithmetic correctly. It should have been the way they wrote it, 32, which would have flipped them back into an even term. But what they did do is they knew once they got their wrong number of 33 to go ahead and use that same part of the sequence. So the student on the right is showing much more understanding of the concept of sequences and of the use of a piecewise defined sequence than the student on the left. Okay, David, go ahead to the next slide. Now here's the thing. Another standard that I typically look at is I have these things called mathematical practice standards. These are taken from the Common Core. They're adapted from the Common Core standards for K-12. So in addition to looking for the mathematics, I'm looking for some core principles of mathematics. In this case, looking for and making use of structure. So in this case, really, this is where I really wanted to see, do they understand piecewise defined? And hopefully most people would agree with me. For time's sake, I'm going to not pull it again. But the student on the left is showing no understanding of sequences and no understanding of piecewise definition, whereas the student on the right is showing that they can make use of structure even when they make arithmetic errors. Okay, I'm done, David. I don't think, do I have, yeah, so we'll go back to Amanda.
Yep, so we're gonna skip back to Amanda, who's back again with us. So Amanda, over to you.
Sorry, my internet's been in and out all day. I don't know where I left off, because I was still talking until it kicked me off. So I use the mastery-based testing that David uses similarly, and we have an example question that I actually haven't ever used because I usually teach Calc 2 or above, and so and I like this problem because one, it's easy for us to kind of remember basic algebra, but also because I think it demonstrates a little bit of what can happen when you think you've written a good problem and you're not quite sure if, you know, like after you actually see the solutions, you're not sure if you have written a good problem. So this concept that we have is finding equations of lines. We have a little bit of like sub things. A student should be able to find the slope of a line, can apply the point slope form of line to find the equation of line, and write a line in slope intercept form. And so the question is, write an equation of the line passing through these 2 points. And we have the solution on the left. And then we have 3 different student solutions. So I'd like you to take a moment to look at student solution A, and I want to ask whether or not you think it demonstrates mastery or not of the question or of our concept.
Just as a reminder, this is only for student solution A.
Right, for A. Oh, and we can't see student solution C, so
I'm able to see it if I make sure my meeting controls are not up.
I can read it too, but we're just talking about A right
Okay, we're at almost 75%. I'll end this in about 5 more seconds.
Okay. So for this particular problem, what was their mistake? So they were able to find the slope correctly. They put it into the point slope form correctly. They just had a distribution error. So when if I were to grade this, I would give this a mastery because they are demonstrating being able to write everything, like write an equation of line and slope intercept form. They're able to apply the point slope form and able to find the slope of a line. It just was an arithmetic error, kind of a clerical error. But this is something that happens all the time when you're grading mastery. And this is where kind of, in my method of like using mastery grading, it's a little bit tough to kind of decide what to do sometimes, because I feel like you have, in your math courses, you want your students to have that precision or a precision of detail. And it doesn't really show up here in this mastery concept. But I would give this a mastery grade because they've demonstrated the concepts. I'm not grading on the like they've made a clerical error, arithmetic error. Let's do student solution B. So what about student B? Do you think this demonstrates mastery?
So the votes are coming in really fast for this one. So I'm going to end this one a little bit early because we're already at 85%. So 5 more seconds.
So 97% say no, and I would agree that this is close. This would be kind of my journeyman or progressing. They hit some of the mark, but they need to be able to find the slope of a line, and they were able to demonstrate in this. For student solution C, the line that's missing that you may not see is that they have found this slope, 3/2, and then they've written y is equal to 3/2 x plus 4. So my question is, do you think this demonstrates mastery?
Again, results coming in very fast. I will end this one in about 5 more seconds.
Oh, no.
Okay, Amanda, can you see those results?
I think she's frozen again.
Oh, okay, I see. So it looks like we have, oops, it looks like we had about 93% saying no on that one. And as I am looking around here, I haven't actually paid close attention to this one. I'm sorry. Is anyone else willing to pick this up and say something about student solution C?
Sure, I'll take this one on, David. So the issue here, and I would agree with the majority of the people, is they didn't keep the components of the points together. So they reversed the X's on the bottom compared to how they did the Y's on the top. And for me, at least, that's going to really cause me to question what if they have a true of an understanding of how the slope works in its computation. And additionally, they didn't show any of their intermediate steps, so I don't know how they got to the 3x plus 4. So I'm not seeing any. A lot of times when I'm doing mastery, I'm looking for evidence. It's not so much whether they got it right or wrong, but I'm looking for evidence, and I'm not seeing sufficient evidence in this particular work.
Yeah, I would say that the student C is definitely showing novice work. But I agree, like when you're looking, so notice that in all 3 of these solutions, they're not completely correct. And so I think we were talking before how, you know, sometimes you feel like you can only give mastery if it's exactly a perfect solution, and maybe that's not the case. But one of the reasons why I like this problem is that my question is, when you look at the question, it just asks you to find an equation of the line. Am I setting my students up to be able to actually be assessed through all of these concepts that I want? If I want them to be able to write a line in slope-intercept form, I'm not really prompting them to do that. They could just write the first equation in point-slope form, and they'd found an equation of a line. So one of the things I found when I've done this type of mastery-based testing is that sometimes you think you've written a good problem, but it doesn't actually assess what you want. Or you are like in this particular case, you know, if I want them to be able to apply point slope form and slope intercept form, maybe I need to change it to say, write the equation of the line in point slope form and in slope intercept form, to be able to allow myself to be able to assess this concept. Because right now, if a student just wrote the equation of the line, I don't know if they can write something in slope intercept form or not. And I think that's something that you should think about when you're actually writing your concepts. I had a similar problem in linear algebra where I asked them to show something was a subspace, thinking they were going to use a subspace test, and several of them wrote it as a spanning set and said, hey, it's a vector space. And so then I had to rephrase my question to say, use the subspace test, because that's what I was wanting to assess. And so you have a lot of these like little like muddy things of like, okay, I didn't care about the algebra mistake in solution A, but you know, in calculus, when is forgetting a plus C okay? So those are the types of questions. Is it never okay? Is it okay sometimes? When do you want them to like be able to completely integrate a problem, or is just setting it up okay? Another kind of question is, what do you do if you have multiple parts in your problem and they demonstrate mastery on 3 of them and they do kind of a medium job on the 4th one? The question is like, what are you going to do in those cases? And I feel like this is where kind of like it gets a little muddy. And I usually use what Austin Moore usually asks, and it's, will this student benefit from looking at this or looking at this again? And if the answer is yes, then they probably shouldn't get a mastery. But I like this problem because I feel like it's a flawed problem, even though like it's kind of straightforward. But that's the end of my question.
So Amanda, there's a couple questions in the Q&A that I was hoping you might be able to address with this one.
Yeah.
which is, and one of them is just about the speed, like how fast does the grading go with this? And the second is then how subjective do you find this to be?
So it goes very quickly. So I like grading mastery because I feel like it's a lot easier to decide mastery, progressing, or novice, rather than thinking, okay, for this point, how many points should I get off? And then I start making this long, like detailed rubric of keeping track of, like, for this error, I take off this much, for this error, I take off this much, and trying to be consistent. I feel like for subjectivity, so I do feel like, I think even when you're grading traditionally, you're a little bit subjective. So I feel like it's hard to get away from that. And I feel like this is a fairer subjectivity, I guess, than maybe traditional. Because you're still, when you're counting how many points do I take off for this or that, that is kind of your decision. And when you make your rubric, that there is some subjectivity to that. I feel like this gives them a chance to reassess and learn from their mistakes better than traditional. And I will say this, if someone is borderline and it's their last chance at a concept during finals week, I'll probably give them the M, because they won't have a chance to reassess or demonstrate later.
And one last question for you. We're addressing some things in Q&A, but I think some of these are good to say out loud. How much feedback would you give a student, and what level of specificity?
I usually give similar feedback on how I would do for traditional grading, maybe a little bit less, because I usually post solutions to my exams anyway, so I'm usually not writing paragraphs of feedback. I don't think students actually read it. So I think, I guess I give kind of roughly the same feedback, kind of regardless if I'm doing mastery or not. I would probably circle where they made an error. Even if they got a mastery, I do kind of say, like, hey, you made a mistake here. So I'm not sure if I answered that well, but.
Thank you very much. So I think we are slightly out of order, and so I'm going to step through Sharona's that we talked about and introduce Gloria Ramos, who I hope will say a little bit about herself as well.
Hello, everyone. I'm Gloria Ramos, and I teach physics at Citrus College, which is a small, for California, community college east of Pasadena, and our students are commuter students. It's also a Hispanic serving institution, kind of covering kind of east of LA County is where most of our students come from. So I've been using mastery grading now for 3 or 4 years, something in that ballpark. So if we can get the next slide, we'll jump into what I do. So right now I'm using 3 different types of standards, or I use outcomes to be kind of consistent with our LMS. So there are some what I call skill outcomes, which are really straightforward things that students should be able to do by the end of the semester. So it's typically, can they calculate something? Can they draw a certain graph or diagram that's important for physics? I have these broader mastery outcomes that provide more of a big picture type of evidence for me about what the students understand, and some that involve basic scientific practice or professionalism. So those might include things like following lab safety protocols, working well, as a team. And so students who can do the skills don't necessarily, several skills tend to be related to a mastery outcome. So just because they can do the skill doesn't mean that they can actually show evidence that they've mastered one of these sort of more mastery outcomes. So the way you kind of want to think about it is that the skill outcomes are very specific close-ended questions, right? Can they do this or not? And that's generally how I grade them. They can either do that thing or they can't do that thing. The mastery outcomes tend to be more open-ended questions where they might have to use some skills, but then they also have to show sort of evidence of deeper understanding of the course material. So they might have to make assumptions or explain or refute arguments. And so those are graded more in a mastery. So they've mastered it. They've shown me evidence that they can do that. I use R for they need to review it, revise it, maybe resubmit it. That's the way I tend to explain it to the students. You need to resubmit that. Or show me more evidence. And the N is that there's just not enough evidence for me to make a call about that mastery outcome. So if we could go to the next slide, please. So here is an original textbook problem. Actually, I think this is a workbook problem from Knight Physics for Scientists and Engineers. And it's a pretty straightforward problem. How much work is done on the gas to compress it in this process. And this is the type of question that students could answer by essentially plugging into the work formula. And that doesn't really tell me anything about whether they actually understand things about work and what that implies for the gas, kind of the physical processes. And this was a thing in physics for a long time, that we were asking questions that told us more about what equations students could use and not necessarily the physics that they knew. So if I wanted to phrase this question in terms of skill outcomes, if I could get the next slide. I would be more specific, right? So I would want them to address the skills related to the bigger mastery outcome about thermodynamic devices. So here I might ask them to draw the pressure volume diagram to apply the first law of thermodynamics. And so they can either do those things or they can't. And these are sort of stepping stones to that sort of big mastery outcome. And seeing, whether they can do these skills or not, or to what degree they can do these skills or not, informs me also in terms of what I might need to review with students. Next slide, please. So again, here's the same situation, but now it's phrased as a mastery outcome. So the same sort of STEM part about this process where pressure is proportional to inverse volume squared, but now it's a more of a context-rich problem, right? You're designing an engine where this inverse volume squared process replaces adiabats in the Carnot engine, and there's some limitations there in terms of volume. And so here's this open question, right? What can you tell me about how this engine will operate? So students should immediately be able to kind of use the skills, right? They should be able to draw the PV diagram for this. They should be able to apply the first law of thermodynamics to this. But they also, to show mastery, they want to kind of consider other things, right? So they might want to compare this one, the efficiency of this engine, to the Carnot efficiency. They might want to talk about the hot and cold reservoirs and kind of any implications about that. So it's open in terms of what information the students can provide. And so I have an idea of what is the minimum I can expect from my students. And the minimum is typically related to those skills. And then what I use my professional judgment, and I think we'll hear this a lot about, well, what is the extra stuff that they can tell me? Another way that I do these mastery questions is I frame them as a student debate. So I might take this question and I say, students are discussing the above situation where the Carnot, the adiabats in the Carnot engine are replaced by the inverse square volume. You know, Becky says that this engine won't work. Alfie says, it will work, but it's going to need hotter and colder reservoirs than the original Carnot engine. So I kind of give them different kind of scenarios. And then I just ask them, who do you agree with and why? Or can you refute the students you don't agree with? And so this, I think, shows, first of all, it's more, I think, real type of questions than just calculate this. And they have to be more thoughtful. And all of these types of open-ended questions follow my format of they have to justify or support anything that they write to me. So the evidence they can provide is either data, so stuff they calculate, and or physics laws that apply. And next slide, please. So this is one of the rubrics that I use. This is a claim evidence reasoning. And so I highlighted here in yellow what I typically see. And that is students are usually pretty good about a claim because the claim is essentially their answer, right? And they usually have an answer. And they're also usually pretty good about the evidence, especially if that evidence is part of the question, right? So here's a velocity versus time graph. What's the acceleration? So they're pretty good about that. The part that they struggle with is that sort of deeper critical thinking stuff, which is the reasoning. So very often they'll repeat the evidence, but not link it to the claim, which is where the physics comes in. So I've started this semester to sort of explicitly require my students, at least at the beginning of the semester, to identify the claim, the evidence, and the reasoning. Because if I left it open to say, make sure it has a claim, evidence, and a reasoning, I got a lot of claim and evidence and very little reasoning. So if we could go to the next slide. Here is an example. So this is the same example. This is the one of the questions. So this is part of a longer question. And this part is one of these explain questions where I use the claim evidence reasoning rubric. And for the sake of time, I won't kind of do the poll, and also you math folks don't care about work. So this is just explain whether the work is positive or negative. And so here are kind of three examples. This yellow one is a typical student answer. This is a question I actually used this week. So the claim, yes, the work is going to be positive. The evidence and the reasoning, well, it's a compression. So compression is happening, therefore the work is positive. And that's something that we talked about, right? And I did emphasize, emphasize is a strong word maybe, but I did talk about how it's important to know whether the gas is expanding or if it's a compression in terms of work so that they can double check their own work. So the focus on this one, there isn't really any, it's just really a repeating in a slightly different way the fact that the volume got smaller, right? That's just what compression is. So they didn't really link it to how a decrease in volume means that the work is positive. So this yellow one might get an R. This pink one, you can see the claim is that the work is positive. The evidence was given in the question, and then to somehow link the evidence to the work, which you can see here. So work is force and displacement, the dot product of those, and so both of those are in the same direction, so the work is positive. This blue one, so this pink one, sorry, this pink one is like, yeah, they've met the claim evidence reasoning on this particular question. And this blue one, there's no evidence at all, right? Work done on the system, as if emphasizing the work on makes it clear of what the physics is going on. So they're just restating the claim. And that blue one would definitely get an N from me, insufficient evidence. And I want to mention that this is actually the textbook solution for this question. So whoever wrote the solution for this workbook would not probably do well in my class if they keep answering stuff like this. So that's just a little taste of what I do.
Thank you very much. And I want to point out too, for anybody who has their hand raised or has other questions, that we will move into a panel portion of this as well. And there's also a Q&A pane that you can ask things in. But in the panel portion, we will also have the option to raise your hand and ask questions. We're going to move to our last speaker in terms of the examples right now, and that's Robert Talbert. So Robert, if you could take on over.
All right, thanks, David, and thank you all again for being here today. Again, my name is Robert Talbert, and I am a professor and the current interim department chair at Grand Valley State University. And I wanted to spend a little time talking about some examples of how I've been using mastery grading in proof-based situations. I don't often teach proof-based courses. In fact, most of the courses that I teach are not proof-based. They tend to be pre-calculus, calculus. Discrete math has some, I teach a lot of, that has some proofs in it, but they're fairly low level. And I've been using discrete math. Actually was the first course. Discrete math for computer science is the first course where I used mastery grading back 4 or 5 years ago. But as I've also taught modern algebra, first semester modern algebra, and our intro to proofs course. And I feel like mastery grading is a really outstanding platform for doing student assessment and feedback in proof situations. David, go ahead and go to the next slide here. And what I use in my proof-based courses, a lot of us in the department use, is a portfolio-based system where students submit different proofs. Maybe there are, say, between 10 and 15 proof-based problems that students are to complete throughout the semester. And they submit either all of them or a subset of those, and each of the work on each of those problems is graded separately. I used to grade these with points, and grading proofs with points is really just a horrible idea, I think. You know, what is the difference between, I would just spend hours and hours and hours nitpicking between, okay, is that a 10 out of 12? Is it an 8 out of 12? Is it a 0 out of 12? Is it and just spending endless amount of time just agonizing over point allocations for differences that don't really, that are just imperceptible. And so one of the first things I did was move to a 4-level rubric. This rubric has gone under, there's always 4 letters attached to it. Here it's listed as E, S, P, and I. I'm going to drop a blog post of mine into the chat window here over just right now, where it's also gone by the name EMRF, and I've used EMRX. And anyway, whatever the labeling is, we have 4 levels of how proofs are evaluated. E means the work is complete, it's precise, it's correct reasoning, full support for all claims, no mathematical errors, no communication errors, no syntax, no semantic errors, high level of understanding. E stands for exemplary, and literally a proof that gets an E would be an example that I would feel very comfortable doing in a lecture if I were into lecturing anymore. An S means satisfactory, okay? It's complete, the proof is complete, there's no big holes in it, correct reasoning, all the claims are supported. There might be a few isolated errors in math, some in the writing, some in the reasoning and notation, but these don't affect the overall approach to the solution. Generally, S means good enough, not perfect, and that's something that has been brought up again several times today. There's no sort of mastery. You don't see the word mastery appear in this rubric here. We're not looking for perfection. We're looking for good enough. It's almost like when we submit journal articles to a journal, okay, we get them often, usually, at least mine do, get sent back to us, and they don't have points attached to them. They'll say, well, this journal submission got a 72 out of 100. It comes back and says, well, it's not quite good enough yet. You need to do a revision. Okay, and then we send it in, and hopefully we just keep revising this paper over and over again. And eventually it becomes good enough. It's not perfect, it never will be, but it's good enough. It's perfectly good for human consumption. And that's what an S here represents. A P stands for progressing or partial understanding, which means that you can definitely tell the student understands the concept and they're on the right track, but there's some sort of significant issue with the completeness. There's a hole in the reasoning, correctness, or some sort of error in a definition or computation. The language is imprecise or the logic was off somehow. And so that needs to be revised, okay? And that's what students will have the chance to do, is revise and resubmit over and over again until they get an S or an E. An S or an E will be considered, it's good enough, you don't need to touch this anymore. An I stands for incomplete, and that just means there's either lots of gaps left in it, or like the student only did 1/2 of an if and only if proof, or it's just so out there and there's like nothing there to really assess. I mean, I don't even know what I'm looking at if I'm looking at an I. So rather than try to describe all the errors that are in this proof, I just say, go back and start over. That's what an I represents. So E, S, P, and I, and that's our 4-level rubric. We're going to look at a couple of examples here in a second, but I will say that for me, this saves a ton of time. I think most of us in the room, if we're looking at proofs or other sorts of conceptual communication type of solutions to student work, we can often judge whether a proof is good enough within seconds of looking at it. You know, we're quite well trained at this. Excuse me. Let's go on to the next slide and let's take a look at some examples. These are all examples that I have made up myself for my students to practice with. This is something that I give to my modern algebra students at the very beginning of the semester, some sample proofs that they have seen in their intro to proofs course, real simple stuff, but I actually have them work through this as an exercise with clickers. I will give them a proof like this one, a problem with a proposed proof, and I will ask them, we'll explain, as I just did, the rubric, and I'll put up a little poll. We don't have a poll today because I know there's a lot of reading. I don't want to overdo it here, but I'll give them a poll on their clicker software that says, what would you grade this at? E, S, P, or I? And just take a poll and we have a little discussion about it. And it's very, very interesting to see what students think is excellent versus satisfactory versus progressing. So here's an example here. We're going to try to prove that if n is odd, then n squared is odd. This is an old chestnut from our Intro to Proofs course, and it's a cornerstone of a lot of other proofs. And so you can see the student here says, suppose that n is an odd integer. For example, let's take 5. Okay, and if you take 5 and you square that, you get 25. And hey, look at that. That's also odd. In fact, check this out. I'm going to calculate the squares of 7 different odd numbers, and they all come out to be odd when you square them. That's incredible. So we see from the pattern, if I had a nickel for every time I heard that, we see from the pattern that every time we square an odd number, you get another odd number. End of proof. And so this student, this is one that I made up myself, but it's very true to life. And I think if we've taught proof courses before, you've seen this. Like they'll do a few samples and say, the pattern continues. The pattern is obvious. And so we end up. And so I don't have a poll here, but think for a second, just how would you have graded this? E for excellent or exemplary, S for satisfactory, P for progressing, or I for incomplete? So this one for me was an I. This is not even a proof. This is just 8 different examples of how things work out correctly, okay? So I would give this student an I for the grade and explain a proof has to be a clear and correct explanation of why the problem statement, the statement in the problem is always true, okay? And we haven't done that, okay? We've explained, we have demonstrated that it is sometimes true, but lots of false statements can be sometimes true. So just giving me examples doesn't necessarily prove anything. What you need to do is come back again, redo this, start over, and give me a general argument that works in all the cases that it's stated for. Okay, David, let's go into the next slide. And here we have the same problem with a different proposed proof. Okay, so this time, at least we're not giving examples. It says, suppose that n is odd. That means we could write it as n equals 2k plus 1. If you square that, you get this, and they have expanded that to 4k squared plus 4k plus 1 equals 2j plus 1, and that's odd. Okay. So again, no poll here, but take 5 seconds, 10 seconds to think about this. And how would you grade this? An excellent, satisfactory, progressing, or incomplete? I see stuff going in the chat. I don't know if you can hear this, but I have 4 cats in my house, and one of them behind me is having an absolute fit about this. I think he's trying to grade this proof, and he's like crying out for a certain grade to be given. I could pan over to him in a second. I would give, okay, I see a lot of S's, but actually I give this one a P for progressing. And I'm wondering if the reason I would give that a P is because of imprecision in the language. I'm pretty particular about quantification on these proofs. I think that grading a proof is a lot like grading a computer program in some ways. It has to compile properly, right? And the problem that I would have with this proof is that it never quantifies what J is, and it never quantifies what K is. Okay, is K an integer? I don't know, it's just a letter of the alphabet that appeared out of somewhere. The letter J just kind of appeared out of nowhere. And so if the student wants to get, for me, that's not quite good enough, okay? I want to have pretty high standards when it comes to these things. And one thing that I think is important about mastery grading is that it gives us instructors permission to hold pretty high standards for these things. Okay, we don't have to compromise on quality if students get this access to feedback and revision and resubmission. We can say, I think that satisfactory is something like an 85% level. Okay, and so in this case, I would give this a P. It's definitely on the right track. Definitely, and this is the feedback I would give to students. Definitely partial understanding of the information. You definitely are not misunderstanding the important stuff here. And you're definitely doing some right things here. But you might want to watch your quantification. Like that K, what is it? That J, what is it? How do they relate to each other? And make that clear and then resubmit it, and I think you're on your way. Okay, let's go to the next slide, David. And here is another example of what we see of the same problem, different proof. And I won't read the whole thing for you, but this one let's see, let me read this one because I've made up several variations of this. And yeah, this one would get an E on this one. Yeah, for sure. Basically, this is what a student would resubmit after they submitted proposed proof number 2. Okay, they turn it in, they get the feedback that there's imprecise language, and they come back and fix it for some integer K. They've specified what J is. There's really no gaps in this. It's well communicated. I wouldn't have any problem putting that in a textbook if I were writing a textbook on how to prove a square of an odd integer is odd. Okay, so that's truly exemplary stuff. David, did I have another slide after this one? I honestly can't remember. Yeah, here's one that's, again, same problem, different proof. Suppose n is odd. That means we can write it as this. Suppose that squaring gives this. Therefore, n squared equals 2j plus 1, and so n squared is odd. That would be, so what do you think about this one, folks? Is this an E, an S, a P, or an I? Exemplary, satisfactory, progressing, incomplete. Now one of my other cats is meowing at the top of her lungs right now, so I don't know if you can hear, but it's us at our realist, right? That's what this is all about. Okay, a lot of P's on this one. Those of you who are saying P, if you could drop something in the chat window, why a P? Why not? I think definitely not an I. This is definitely not just completely out of left field here. Yeah, so we haven't specified what J is. That's kind of a problem. Doesn't quantify the K. Yeah, so quantification is really an important issue because, I mean, if you don't specify that K isn't, if you just want to say that an integer is odd, if you can write it as 2K plus 1, then I can say that 3 is odd because I can write it as, 2 times, I mean, I can say that 4 is odd because it's 2 times 3 halves plus 1, right? So quantifying the K as an integer is really, really important here. Yeah. So that would be another version of the P proof you saw a little earlier. Right? I would say this, when I give this to students to grade it themselves, they often miss these things, but they often catch them. It's really interesting to see if they are grading somebody's work other than their own. They are incredibly perceptive and incredibly tough. I mean, they will give P's and I's to like everything. I put some of my own proofs up before and they will just rip it to shreds. And man, you guys are a lot harder on each other than you are on me. And this builds the habit. I hope that it builds the habit when I give this exercise to students at the beginning of a semester, the habit of self-assessing your own proofs before you hand them in, right? Which is what professionals do. I mean, when we're submitting a paper to a journal or submitting anything for evaluation and it matters to us, we're definitely going to sit down with the standards by which we're going to be judged and just make sure all the boxes are checked off before we make any sort of moves on this. So I feel like this example of mastery grading with students, making the rubric public and giving them plenty of exemplars and using this as a class activity to check each other with is a great way to build these good habits of mind and get students on the road towards self-regulating a little more than they used to. Was that it from me, David?
That is. Thank you, Robert.
Okay. Thanks a lot.
So this is our breaking point between the two sections, but we're not taking a break. So we're going to switch over because we can see there's tons of questions going on. We're going to switch over to a panel format at this point. And so the panelists are the four speakers that you just heard, Amanda, Gloria, Robert, and I'm looking at it and saying, who did I miss? Oh, and Sharona, I'm sorry. Sharona will be helping moderate this. We're also going to have Drew and Rachel, who you heard this morning, as some additional panelists. And our goal here is to take your questions about how all of these things work. Before we begin that, I want to say a little bit about things that you might not want to ask questions about because we're going to have some detailed sessions on them later. So these are things we'd rather not focus on too much just because we're going to coming up tomorrow. So we have dedicated sessions on creating standards, objectives, and specifications. We have another session that will be coming up on managing reassessments and time, and another one on communicating grades to students using LMSs and things like that. So if you have questions that are in these, please realize that you will have a chance to ask them, but that now might not be that we might have more responses and more time to think about them coming up tomorrow. Okay, so Sharona and I are going to be collectively moderating this. We have a couple of preset questions that are taken from your pre-conference assignments, and we're also going to look at the questions and the raised hands in the Q&A and in the participant list. Sharona, is there anything additional you'd like to say about how this goes?
No, just to remind people to please raise your hand if you would like to be invited to talk live, and Bosley, who is hosting our session, will give you permission to unmute at that point once we call on you. And we are going to be monitoring the Q&A. It's a little harder to keep up with questions in the chat because it's going by very fast. So if you specifically have a question that you want one of the panelists to answer, to put it in the Q&A, that would be a better place for it.
So I'd like to begin with something that I think is on all of our minds, which is the question of, can mastery grading work in online classes? Is this something you could actually do right here? And so do any of our panelists want to say something in particular about that?
I can start. So I was originally worried about this when we moved to online, and I was teaching a mastery-based testing linear algebra course this spring, and actually I was working with another colleague, and that I really recommend. If you can find a friend to do mastery-based mastery grading with, it really helps you. It's good to have another pair of eyes on the questions you write and to be able to kind of, you know, bounce ideas and about like, oh, would you give this a mastery or not? Like, it also is nice when you have multiple sections of the class if they're both being graded kind of the same way. But both of us had the question of, should we do mastery-based testing when we move online? What he did was he moved it to be take-home mastery. So he made the questions longer and harder. And he then told me, don't do this. It was terrible because it took him a lot longer to grade. And also we found a bunch of our problems on Chegg. I didn't do that. What I did I kind of kept it the same way I would have done in person. So I have my, in this particular 3 credit hour course, I had 3 exams and 3 testing weeks. And so I gave them their exam, and I made them do a video proctor of like we used Respondus for them to go through the work. I made them have to type a little bit of the question solution in the checkbox, and then they had an adaptive release assignment that they uploaded their work for within like 10 minutes after. During the retesting weeks, I split up all of the different concepts into their own exam. And I gave them about 15, 20 minutes on each concept for them to do the problem and upload their work. And so it worked all right. It wasn't great. And so just a reminder, for my retesting weeks, they're able to retest any past concept once, but at any time. And so I was able to do this. I didn't find many of those questions on Chegg because they didn't have as much time. But something you have to think about is if you're going to give them all the concepts and they get to pick which concepts, and you're doing mastery-based testing, it's better for them to master one concept than get like progressives on everything. So do they have enough time to send that question to Chegg or to someone else, or use Discord to talk about that question and split up the problems? So I feel like that's something I was worried about. But I was surprised. I felt like a lot of the answers I got seemed pretty accurate to what the students were doing in class beforehand. And I feel like when you have mastery-based testing, you have a high bar. And so if they're mimicking or trying to like, you know, find someone else's solution, I feel like I felt a little more comfortable with that than like the take-home exams. But I do think those are some concerns or things I had to think about when I was doing this. I don't have a great solution to it. I'm planning to do mastery-based testing for at least 2 of my classes in the fall, and I haven't decided about my 3rd one.
Thanks, Amanda. And I actually was going to chime in on this as well because I found that my switch to online went quite smoothly. My exam, or parts of one exam, did show up on Chegg, and that person was very quick to be caught. But what I would say is, if you're using some of the LMSs and some of the tools out there, there are some ways to go ahead and do your mastery quizzing through your LMS, put in very easy versioning, other kinds of things that will allow you to catch things. But another thing that I do that I have found makes it easier is I actually have my students do their work on paper, and then I have them take pictures and upload. When they have to really dig in, even if they're trying to get it from another source, I find that they still do much of the work. And because I'm looking for very specific evidence, and they know what that evidence is, a lot of times the work that is shown in an answer that's online or on Chegg is not a match for what I'm assessing. So if I'm assessing, you know, integration by parts, they're very clear that they need to show me all the different pieces and why this would work. And I may ask them, how can you tell that this is the inverse of the product rule or chain rule or whatever the different things are? And by making those connections, those become very hard for other people who are not in my class to answer. The other thing I do is I use the tools in the LMS to provide asynchronous opportunities to test, but time-limited testing. At our institution, we don't support, we're not a big fan of the proctoring situation because it can be very invasive for our students who are, a lot of whom are dealing with some pretty difficult things, and a lot of them are taking their exams on their phone, so trying to do a proctoring doesn't work. So we found that by utilizing the tools in the LMS, we're able to do versioning, we're able to do all kinds of things that actually are too hard to do in an offline class. The way that I version, almost every student gets a unique exam, and that has really cut down on it. And then the ones that cheat, we catch them really fast because their answers don't make sense relative to the question. I had one other real quick before we go to another question. There was a conversation in the chat, and Amanda, you just mentioned working with someone else. I'm a big fan of what we call normed grading sessions, which is where you get together with other people. And we did this within the actual course that I coordinate. You all get together with real sample work. and you go through it together, 2 or 3 or 5 samples, and you come to a calibration where you agree, this is what mastery looks like. And that's really, I think it's been a great benefit for me. And that's what Shira had asked, what is a normed grading session? It's when you work with other instructors on the same course to agree at your institution in context, what does mastery look like?
And I just want to tag in real quick to follow up with what Sharona was saying. For my kind of more open-ended questions, even if a student could Google something similar in Chegg, I require my students to basically do a video of themselves explaining their solution. So even if they copied it from Chegg, if they can explain what that solution is, that for me is a win, right? They kind of understand the physics behind it if they can explain it. So that's one adjustment I've made for doing stuff online.
Would anyone else like to address this before we move along? Oh,
I
Rachel,
did forget to say that, like, I did use the random pool generator for questions, and like, so students knew there were lots of different versions of the questions out. And so I hope that discouraged them collaborating.
Could I just go in a slightly different direction with the question in terms of if you're thinking for the fall, I may be teaching online completely or partially, should I also be switching to mastery grading? And I think this has already been mentioned in other sessions, but I wanted to emphasize that I have never taught an online course. Obviously I've taught remotely now, but I haven't taught an online course, but I've been reading about that in preparation for the fall. And everything I read suggests that you need to have a really complete picture of your course, like in ways that we don't have to in face-to-face. Like you need to have it all laid out and ready to go. And part of that is knowing the objectives and knowing where your course, what you want your students to get out of your course. So basically the process of figuring that all out really mirrors the process of creating a mastery grading system, of thinking about what are my priorities here, what do I want my students, where am I going to put the emphasis? And so I think in that sense, they really meld together well. As Sharona mentioned, like when I went remote, the grading side of it was not an issue. It was the content delivery part that I had to figure out, but the grading, I was already getting everything on Canvas anyway. So, and my students knew what the objectives were, so they knew where we were heading. It was just how do I get them there? That was the remaining question. So I think they go together really well.
I'd like to elevate something that I saw in the chat from Justin, who just mentions that for online mastery assessment, a really important thing to do is to establish a culture of explaining answers in words at all times, and that how that needs to be a part of demonstrating mastery. And that this can help see if a student really is using their own words and if they are understanding what you're asking. I would like to move to a second question here, which is another big one. And we've answered a few of these in the Q&A, but I'd like our panelists to think about these overall, which is, how do I get buy-in? And buy-in is a broad topic. So how do I get my students to buy into this weird grading thing I'm doing? But also, how do I get my colleagues, my department, my institution, whatever the extent of that may be? How do I convince them of this? Especially, say someone is a contingent or pre-tenure faculty. Kate.
Hi, everybody. So I'm Kate Owens again. I'm in the College of Charleston. I am not a tenure track faculty member. I'm not on the tenure stream. So I have an instructor position, and it's more stable than an adjunct position for sure. I have a rolling cycle for my employment here. And so I started using mastery-based grading before my third year review, and it definitely was something that I thought about how this would be perceived by members of my department, how this would be perceived by members of my school and by the university as a whole. I think that when I asked other faculty on campus and people that I respect, what do you think about this approach? How can I show the best side of what I'm doing? A lot of the advice that I got was that, if you're being very reflective about your teaching practices, you want that to come across and your teaching narrative and everything like that. So really spending a lot of time thinking about the way that I build my courses before mastery grading and, using traditional grading, why was I making the choices that I was doing? And I think that mastery grading itself forced me to ask myself a lot of those questions in much different ways, because of the way that I went about building a course or writing a syllabus really changed from, okay, where am I going to put the 3 tests and how will they be equally spaced, into what are the core concepts that I want my students to know? How will I know that my students have learned those core concepts? How can I support those who are struggling to work toward, learning those concepts from my class? And so I think part of it is having some just campus-wide discussions with the people around you about, this is what I'm doing, this is what I'm trying, what do you think about this? What advice can you give me? Those things definitely helped me in my own thought process and everything like that. As far as in the classroom, I think it's the same thing. I think that having just a lot of conversations about the rationale and the reasons why we've made these choices, how we think that it's beneficial, and definitely some of the drawbacks. I think that all grading systems, all assessment systems have their own unique challenges, and mastery grading, mastery-based testing definitely has some of those same bugs, and we have to be upfront with our students about this could mean that you put in more time because you're going to have to reassess that tricky thing. You're not going to be able to slide by just on partial credit. In some ways, I am holding my students to a higher bar, but I'm giving them more opportunities to meet me at that level. So being really honest with them over the course of the semester about the rationale and the choices that we're making has definitely helped. Unlike where syllabus day used to be the first class, or maybe the first part of the first class, syllabus day is 5 or 10 minutes in every class, basically the whole semester, talking about what choices we've made and why we're doing it this way.
I stole this from the IBL workshop. The students on the first day, they share one hobby and how they became good at it, and it's often through practice. And I tell them that the assessment method that we're using reflects that I'm, like, who am I to say at this midterm you should have all of these things, known and mastered. Like, some of you may need to spend more time, or that's how we become good at things, is by practicing and spending time. And I want to reflect that. I think I talk about how I want to level the playing field. I don't want to give, benefit for the person who's just a fast worker. Like, that shouldn't matter. Time shouldn't matter as much. And I feel like this is a fair assessment. I also feel like part of it is just trying to keep your classroom a safe, supportive environment. I feel like if you can really show that you care to your students, that they will meet you halfway and are more likely to give you the benefit of the doubt when you try weird things. But I definitely, like Kate said, reminding them to take advantage of the retesting opportunities, and that's what's gonna cause students to struggle. I've also used past comments from students. I've also collected data from students about test anxiety and growth mindset so that I can share it with my administrators. On my first or my annual faculty report, I pull out all the comments about mastery-based grading and I categorize them so that they can see the response that students have, and they've been very overwhelmingly positive. And so if students, and a lot of them are comments about how much better they learned the material because of the system. And so I use that to kind of help get buy-in from administrators.
Can I just build on what Amanda was saying?
Go ahead, please, Rachel.
Thanks. So I think Amanda might have been referring to the setting the stage first day activity, I think. There's a few other things that I try to do, like as Kate said, my first day is not syllabus day anymore. I don't really do that in class so much. I have them, I have various assignments like having them watch Joe Bowler videos about math myths and growth mindset, having them read, there's a Scientific American article, which I think is by Carol Dweck, that I have them read. There's a good Salkan video about mastery. So things like that I sort of intersperse throughout the semester just to kind of keep that messaging there. And then I have them do a productive failure assignment where they talk about, at any point in the semester they can do this, where they have some topic that they've struggled with and that they've worked through and finally come out the other side. So they kind of write up a little reflection on that and describe that to me. And then I have them do other reflections throughout the semester having them pause and think about how are things going so far, how do you feel about the grading system, those kinds of things. So as Kate said, just kind of keeping that messaging going. It's not a buy-in on day one, it's a buy-in throughout the semester that you have to keep selling it and explaining it and giving your rationale really. And if you have a solid rationale for it, I think they'll go along with it.
Okay, anyone else? Gloria, did you want to jump back in there?
Yeah, just a couple of things. What I have found is students are willing to try it right once they hear about it on the first day, but I think it's after the first sort of major assessment when they realize, oh wait, I can reassess something I haven't shown mastery for yet. That's when the light bulb kind of goes off for them. And I'm trying to get them to buy in the first place. I also try to emphasize that this type of grading is about providing them actionable feedback, right? That if you didn't score so well on this outcome, it's because you're still struggling on that. And that's probably what you want to review and study. You don't have to study everything all over again. You want to focus on this because this is the part that you're struggling with. Excuse me, that's the part that you're struggling with.
Thank you so much, everyone. Okay, we're going to move into a little bit more Q&As based on some of the chat. So we're going to stop the screen share so that you can see the panelists' faces a little bit better as we go through this, which means I need to turn on my video because that looks really weird. Okay, so we're going to start taking some from the audience, from the Q&A. One of the questions, and this is for any of the panelists, share some examples of activities that you might do with your students to introduce them to mastery grading and help them understand what it is. So does anyone do activities, or when do the students begin to figure it out? Who would like to take that one? Drew?
I'll take that one. I just give Drew's tale of 4 students or 3 students or what it is. I mean, that exact thing you do, Drew, is like exactly what students need to see. These all come out to be the same averages, but they're 4 completely different stories. So why should we give the same grade? And that's almost all the buy-in push that I need to give.
I just want to say that I think what Rachel was saying also about her introductory activities is a fantastic way to help with this. And Rachel, we're going to ask if you can share some links to those videos.
Yeah, I can. I may have them on my website, but yeah, I can certainly look for those. Yep.
So one thing I will say is I do a number of activities where I ask students to decide what grades certain students should get with examples. And so part of it is just training. How do you read what it means to earn an A in this class? And another is to see, do you agree or not? Why did I set it that way? So that is some level of norming right there. Why is an A set where it is in this class? Do you think it would make sense if it were lower? Would that be an A or not? So we have that discussion on one of the early days after they've had a chance to look at the grading setup.
One other thing that I started doing is I do an early mastery quiz. So the class gets to choose one of the concepts from exam 1 before we have exam 1 that they'd like to do a practice mastery concept assessment with them, and they can actually see what they would have gotten. And if they do master it, it goes towards their grade. But then they kind of get an idea of like, oh, this is how this is graded. And then I get to share the responses of anonymous, of course, but what do you think of these types of solutions to this particular concept that you asked about?
I know that my students don't tend to really get it until after the first reassessment. Does anyone else want to share when do their students really finally figure it out? Drew, you want to share on that one?
Yeah, I always make a big deal about it after the first kind of reassessment, but usually when it clicks for them is when I can somehow drag them into my office and have a conversation with them. So that's one of the reasons we were talking about in the chat earlier about different kinds of real minor revisions. A few of us use this kind of asterisk for one of those examples earlier with the series where it was like a +1 instead of a -1, something like that. You give them an asterisk and they have to come to your office and explain what's going on. Now they're in your office and you say, look, you're basically there. You just had to explain this little little mistake, and now you've mastered it. And they say, oh, great. And then they stop asking about the partial credit because they got all the credit instead of getting 4 out of 5 or whatever partial credit they would have gotten.
Okay, anyone else want to take that one? Okay, we have Sandy Jumari has raised their hand earlier on. Sandy, if you'd like to unmute yourself, if you have a question, or if you don't, yeah, the hand went down.
Oh.
Go ahead, Sandy.
I'm sorry. Yeah, it was a mistake.
Mistake?
Wrong.
That's okay. So but the point is it does work. So you can raise your hand and we will notice you and give you permission to talk. So that is another way that you can participate if you feel like your question would be a little harder to put in chat. We have a couple of questions about non-quiz or exam assessments. Like can someone talk about group work or larger activities? How does that feed into this? If no one's, okay, Gloria?
I do have standards about kind of being a good team member and things like following lab safety protocols. And I might have standards on like writing a lab report and stuff like that. And that is kind of, so those sort of more behavioral things are based on my observations, right? So I have a flipped classroom, so I have the ability to kind of walk around my class and see how students are interacting. And that's what I base these sort of being a good team member type of things. If they have a project where they all have to contribute to the project, there is some peer assessment involved. And so that will also inform my choice about whether they're meeting those standards or not.
Anyone else on non-quiz or exam assessments? Rachel?
I can unmute myself. So the way I generally have, like, for example, with my Calc, I'm only using the mastery-based testing for the sort of foundational ideas, and anything more complex goes into an assignment that students complete individually, and they can revise and resubmit those. And so, for example, this past semester I had a graphing assignment where it was, here's a function, here's its graph, go through all the calculus and pre-calculus stuff to explain the different characteristics of the graph, and then they had to write up that whole thing and submit that, and I graded it using specifications. So what I tend to use everything out, like only the most basic stuff goes into mastery-based testing. Anything that requires any kind of synthesis or conceptual understanding, anything like that, goes into a outside of class assignment that's graded using specifications grading.
And just to piggyback on what Rachel says, I've found that using assignments like that with creativity can really get to the heart of whether or not they understand certain things, especially for content at the end of the course. So in Calc 2, we're supposed to get to things like curvature and arc length, and I have real trouble getting there in time. So I do an out-of-class assignment. They can use anything, Wolfram Alpha, whatever, because so what I tell them to do is create a simple closed curve, calculate its arc length, parameterized curve, calculate its arc length, pick a point, and calculate the curvature at that point. And they can't use things like a circle. And I find that this is where you get to understand that they don't really understand that differentiation happens at every point you would check for it, because they ask me, well, what point should I check curvature at? And I'm like, well, anywhere that your piecewise defined simple curve doesn't come to a point. So you can really get some great creativity and really dig into the things they have not yet mastered in projects like that. Anyone else on the projects? Okay, we have a hand from Kara. Kara, did you have a question?
Yeah, thanks. So my question is that I've done mastery testing before, but I find myself to be severely tempted to make the question easier with later assessments as opposed to with earlier assessments. That I find some students that really get it are able to get the assessment right away. And then there's some students that are really struggling to meet the bar that I've set, that is the difference between an M and not an M. And so I find myself tempted to just make the assessments easier and easier as I go. And I don't know if anybody else has come up with a way to either address that scenario or to address the temptation on the professor to do that.
Kate, and then Drew.
Sorry, I had to unmute myself. I have definitely felt that same feeling, you know, that you see a student who's really struggling, you're just like, I think that one of the things that makes reassessments complicated is just trying to ensure that you give the same level of difficulty problem to every student over a particular topic, right? So that, you know, whatever your topic is, you need to develop a problem set that has that same concept or standard or whatever it is, learning target, and have many, many versions of it. And it's really tough to make sure that all of those versions are at exactly the same level and require exactly the same amount of cognitive effort or, you know, arithmetic calculation or whatever the thing is that you're testing. That's definitely something that I've struggled with over the last several years. It is like, you know, trying to come up with 10 problems about whatever, where all 10 problems are at the same level. The way that I have dealt with that situation is that I require my students to demonstrate mastery twice for each of my standards. And so one benefit of this is that I'm not as concerned if, you know, the next person that walks into my office when I grab a random question, are they going to get the super difficult one or the super easy one? I try to make them all of the reassessment quizzes about the same difficulty, but I know that, you know, the chance, since they're going to have to reassess, you know, once or twice or however many times, the chance that they'll get hit over the head with the really, really tricky one or get to float by with a really, really easy one is a little bit lower by requiring them to demonstrate their level of mastery twice. And then I just take sort of an average of those two scores. So if I see, you know, they've got a mix of E's and M's or something, somehow I take that into account and maybe make an M+ or something on my grading system.
Hey, Drew, and then Amanda also wanted to comment.
Yeah, I was just going to suggest, and I know this is sometimes more realistic than others, but if you can front load some of the question writing, it can help a lot with the consistency. If you sit down once in, say, July and write 10 questions for a standard, it's going to be better than if you do 2 in August and 3 in September and 1 when that student comes into your office in the middle of October, and so on and so forth. So that can definitely help there if you can. And again, I understand that this is sometimes more realistic than others to be able to do this in advance. The other thing I would suggest is if you can collaborate with a colleague. I found this really helpful. Stephen Klontz is also at South Alabama, and we've done a lot of collaboration, and also with a couple other people where we each write some problems for a given standard and then collect them all together. So build up kind of this big library. And so that way you're not writing quite so many questions.
Okay. And Amanda.
I kind of have the opposite. I kind of I make them ever so slightly different. And I feel like if anything, they get a little more challenging the longer I have them. But I do talk to my students and I say, look, I'm not making questions where I just change the numbers and you can just mimic it. So they're going to be different. And there's going to be a little bit of difference in, like, you know, maybe you did this eigenvalue problem and you got like 2 unique eigenvalues and this person got 1 unique eigenvalue, like, or like, you know, like 1 repeated, you know, like that's just how, you know, the cookie crumbles with how there's different versions. I felt like that happened a lot with moving to online with having those question pools. And I agree that like writing them ahead of time really helps, but I also found that sometimes writing them ahead of time, then you start making the same problem. And so you have to be careful about that too. So make sure that you're not like allowing them to mimic problems. And that goes into, I think, something that we're not talking about in this panel of like, how do you make rich questions and good questions for mastery? And that is another challenge in and of itself. But I feel like I don't mind making it a little bit like slightly more challenging on the next concept because they've had a chance to see it and had a chance to like practice. But it's usually not overwhelmingly harder. They're still similar.
So I'd like to turn to a couple of questions we have in the Q&A. And Robert, I know that you noticed one of these. The questions are both related to either having TAs, perhaps a large number of TAs, a large section. How would you work with either a large course or a course in which you have a large number of TAs or graders working with you?
Sure, I was just going to address the TA part of that, since our courses at Grand Valley are fortunately capped at a really small size, but we do get graders every now and then. One workflow that I found was very, very helpful to me for grading was in, it was a 300 level discrete math for computer science class. And I had a student who was one of my former math 325 students, was my grader. And we had these 25 standards that students would be quizzed on, like being able to find Hamiltonian path inside a graph and that sort of thing. And they were graded either pass or not pass. It was only a 2-level rubric, just pass fail on each of these. And we had clearly defined standards where it was pass, defined where it was not pass. And so my grader's job was to find the obvious no passes and the obvious passes and mark them and get them out of my way. Okay, so he was my filter for all these quizzes. So if he saw something that was obviously correct and everything looked good according to the rubric, and I worked with the student to train him on the rubric so he had good inter-rater reliability, he'd mark it as a pass. And if something was obviously not passing, like a person left most of the thing blank, he'd mark it not pass, maybe put a word on there about it and move it off to the side. So he would filter out. Typically, about half of the assessments and reassessments I get at every session would be obvious passes or obvious no passes. And so I would only get the ones where it wasn't clear and they needed the professional judgment as to whether it was pass or no pass. And it was easy for him to do because we're only looking for the obvious outliers, I guess. And it cut my workload in half. So I didn't have to spend any amount of time whatsoever dealing with obvious cases. And I felt like that was a really good arrangement of the work. It was never a huge workload for him because he was I told him, if you ever get a paper and you're not sure about it, just give it to me. Just put it in a pile that goes to me. And you only do the obvious ones where it's clear. And if students had the opportunity to get a second opinion, like if they felt that they were marked incorrectly, they could always bring it back to me and I'd take another look at it. But it really evened out the workload quite a lot. And I think you could have even just 1 or 2 graders who knew the material well enough to follow your standards. And that would really, really save some time in the reassessment.
Sharona, I think, did you have anything you wanted to say about working in large courses or multi-section coordinated courses?
Yeah, I've said a lot of it, but the key here is going back to those normed grading sessions. And what we also did is we would have even before we did the pivot, we actually Zoom recorded all of our normed grading sessions for the last 1.5 years. And we would post those recordings online so that if an instructor didn't remember what the norming was, didn't remember the discussion, wasn't able to attend the norming session, they would go and they would view the recordings. And what was interesting is some of our instructors would start to argue with the recordings because they weren't there during the conversation. So yeah, Bosley was one of those. So sometimes that's a really good thing you can do, is you can record actually a conversation that you have with another instructor. Even if you're both live in the room, you can record the discussion with student work showing on the computer, and that becomes a frame of reference to be able to get TAs or other graders to participate in it.
Would anyone else like to address any of those questions? So there's a question that I think many people are thinking about right now, which is, as I'm finding it in the Q&A panel, and I have now managed to lose it in the Q&A panel, so I will paraphrase. People who are worried about, anytime we're talking about creating many versions of the same question or many different questions to address it, is sort of at the heart of some people's anxiety about using mastery grading and having to do that. And so think about something like a proof level class or an upper level class. How do you avoid this issue of binning things into small areas where there are not enough different questions you could create? Or how do you avoid that entirely? Do we have anyone who'd be willing to address that? Rachel.
I just wonder if that's the situation, if that's a good learning objective, or if that learning objective just needs to be tested in a different way. So for example, in a intro to proofs course, I think completely following Robert here, I have like, I can write this kind of a proof, I can write this kind of a proof, I can write this kind of a proof. But then in terms of the trickier things, you move them into a different kind of assignment, like the portfolio problems or something like that. So, so I think that's one question you should ask yourself if you find yourself not being able to write enough questions. Is this the right kind of place for this objective? Is this kind of the right way to assess it? And is it a good objective?
I had a similar question for real analysis. And so I did a similar thing where I was like, I want them to be able to do some basic, like, you know, standard proofs in real analysis. I want them to be able to know basic definitions, basic examples. And those ones I could do like mastery based. And actually, you know, for the definitions, I don't change them that much because I change the order because they still need to know what the definition of a limit is. A definition of a compact set. But I made take-home exams that are assessed orally through oral exams to do those kind of higher level kind of questions that I was like, I can't make a bunch of like examples of this. So I would kind of echo what Rachel said, is that I don't always assess everything. And the same thing with linear algebra. I have a take-home section where like I can ask them to use technology and ask kind of messy linear algebra questions. And I don't do that mastery based because I didn't feel like it fit well.
Okay, we have another question unless anyone else want to. I did have actually one comment on this that I think David may have touched on. If I'm having trouble versioning the questions, often it indicates that there's something wrong with the way I designed my objective, because either it's too simplistic and it's really something that can or should be done by a computer algebra system, or it's not worded quite right and there's just only a few very structured problems that fit that. And generally that means I've gotten a little too deep in the weeds with my mastery objectives. So a lot of times I've had to look at an objective and take a step back and say, okay, what am I really wanting them to leave this course and maybe still have in 6 months or a year or 2 years, as opposed to this very specific skill. A lot of the other things we're talking about at our institution with regards to equity right now is, are we assessing their math or are we assessing their ability to use Google or Chegg, both of which have equity implications. So like we said, there's actually a lot of ways to design much better questions, and maybe having some of those conversations about good question designs, like along the lines of the questions that Francis Sue proposed, may lead us to better objective design as well. And speaking of that, we have a question about IBL and mastery grading. So Josh writes, I find it difficult to design questions that both, one, lead students through new material IBL style, and two, assess mastery, which I usually think of assessing mastery on a topic we've already explicitly taught them. Any advice? So who wants to, go ahead, Drew.
I guess I didn't quite understand the question there. Is the assessment supposed to be over something they've never seen before? Is that what the question was?
I think one of the questions people who are doing IBL have, and I know I struggled with this, is how do you get them to do the IBL activities when those are so different from assessment? Like what's the distinction between IBL, where we're asking these new leading questions, when do you use that, versus assessment, which is supposed to look backwards?
Right. So I guess the way I've kind of interpreted this is that I do the IBL piece on what we're doing in class, right? We're developing kind of the background for all of this through these IBL activities. And then the first time they do one of these, we're doing it in class and it's new and it's done in an exploratory inquiry way. But then after we've done a few of these in class, now it's no longer kind of inquiry now that they've done it. And that's what the assessment is on. So kind of when we do it in class, we're doing the inquiry piece together when they have all that support of their group mates and me walking around. And then the assessment is coming back, okay, we've kind of discovered how to do this particular thing. Now we'll have an assessment to really make sure that everybody has kind of this concept.
Anyone else want to, Rachel?
Kind of along the same lines, I think what Drew said is exactly the way I think about it. And if you look, I'm just kind of picturing in my head my workbook for calculus, for example, which is IBL style. And what I started doing is just flagging the questions that were that were exactly assessment kind of questions. So a whole bunch of the workbook wouldn't have flags on it. And then we might get to problem 3.12 and it's like, okay, that's a PC1 problem. So that's what you should expect on the timed assessment. So it's kind of a mixture, like the leading up, a whole bunch of questions that are not what I'm going to assess them on, but it's what we have to work through to understand the concepts. And then boom, here are the kinds of questions that you could see on a timed assessment, and really highlighting those as the kind of final piece of the topic.
Okay, anyone else on IBL and mastery-based grading interaction? Okay, we have had several questions now about, well, we have a question, I'm gonna paraphrase it. What do you do when this is your first time using mastery-based grading with a specific course and you're not really sure if you're gonna make it through all your standards? How do you adjust if you're not sure what the right quantity of content is at the beginning? Anyone? Kate?
I'll take that one. Yeah, I think definitely my first couple of cycles using mastery grading, I didn't have any of my reassessments written ahead of time. I didn't have a full list of standards. My syllabus said something like, you know, you'll earn an A if 90% of your work is at the E level, and you'll earn a B if 80% of the course standards are at the M level, using sort of an EMRN scale. My intuition was that students who earn an A would be students who had mostly A's with maybe a couple of B's, and students that earned B's were mostly B students, maybe with a couple C's. And so I just sort of did it as a flat percentage without knowing the exact number of standards that we would get through that semester. And then the subsequent semester I was able to sort of narrow down what that number actually was.
Great. Amanda?
So I do think it's easier to do mastery-based testing or mastery grading when you've taught the course before. I had this problem with graph theory. I'm not a graph theorist, but I wanted to teach it to learn more. And so I wasn't quite sure how many concepts I should have, but I kind of was like, okay, it's a 3 credit hour course. I usually have this many concepts. I just didn't tell them what the concepts were. I said, well, I'll give them out, you know, as we kind of go. And then I've had it before, like in real analysis, once we didn't get through as much as I wanted. And I just said, hey, instead of this many concepts, we have 2 fewer. And I adjust the like percentages to be about the same. Like if you master about half of them, you should get a C. And I've never gotten any like students upset about having fewer concepts to master.
So we are coming up towards the end of this. One thing that we're going to hopefully be able to do is put together some sort of FAQ or some additional resources. I'll also mention that we will have more panels, we'll have more sessions, there'll be a lot more times to talk about many of these topics and ones we haven't gotten to. What I'd like to answer is, or end with, is what I think is a really excellent question. We've heard a little bit about this so far. And it's from an anonymous attendee. Can the panelists say something that they did the first time they implemented mastery grading that they would do differently, or something they kept that they think is fantastic?
All right, I'm gonna go first because I can tell you, I have a long list of things that I messed up my first few cycles through. But okay, one thing I'll tell you that I messed up was my initial go at this, I was using a rubric kind of based off of like a GPA scale. So, you know, A, B, C, D. I put it in as A was 4.0, you know, B was 3.0. I thought that this would be good because my students had some kind of familiarity with the way GPA numberings work. And it turned out to be a complete disaster because our LMS, where I was keeping track of people's grades, is really obsessed with percentages. So a student who I thought had done pretty good work, and I would give them, you know, maybe like a C+ with like a, you know, with just a little bit more help, this really could become an A level standard. They'd get, you know, a 2.0 out of 4.0, and the LMS would spit back to them that they had gotten a 50% and were like failing things, when I really thought that they were doing much better than that. So my piece of advice is to like abandon any kind of numeration, Pick letters that the students don't have an emotional connection to already. So when I switched over to EMRF, it turned out that F was like, no one wants an F on a paper. I don't want an F on a paper. Don't give me an F. Like, that's not good. So I switched it to EMRN. And while there's less familiarity about those letters and what they mean in terms of a solution, there's also kind of like less emotion attached to like but I'm a B+ student and I'm supposed to get a B+. We can sort of like wipe the slate clean and start over.
Amanda?
So my first time doing mastery-based testing was in real analysis, and I did no retesting weeks. They only had 4 exams, and it worked okay for real analysis. And then I took to Calc 2, and it did not work. That was not enough time for them to be able to buy in and to like understand the reassessment. That was too much stress. So I immediately started doing retesting weeks in Calc 2. And then I was like, why am I not doing this for my real analysis either? Another thing I did my first year of doing mastery grading was at the end, I kind of, right when I like kind of popped out their grade exam to kind of be like, this is where you're really at. I counted my middle grade, my journeyman or progressing as a few points towards the next mastery grade. I don't do that anymore because I want them to try to achieve the mastery level. But to start with, to kind of get a reputation, I now have a reputation where students kind of like my mastery grading. And if they talk to other students, they're like, yeah, it's good. But when you're starting out, that kind of helped kind of, you know.
I think we may have lost Amanda again, unfortunately. Gloria, did I see you raise your hand as well?
Yeah, my biggest mistake, I think the first time I did mastery grading was I had too many standards, right? I did sit down and think about what student needed to do or be able to do by the end of the semester, but I wasn't as thoughtful about it as I should have been. So even though I looked at my assessments, I didn't really try to figure out the big picture, the bigger structure for the standards and what are the things that I really needed to track and give them multiple opportunities to do versus things that I know they'll pick up because they have to. So that was my biggest takeaway, because then that led to kind of all those other things, right? I was trying to retest so many things and trying to keep track of so many scores that it wasn't helpful to the student. So I had to sit back and say, well, if a student doesn't meet the standard, how important is that information to the students, right? So can that be part of a bigger picture type of standard? Right, so that if they meet this standard, yeah, they should be able to do these things, but I don't need to test them every single time that they need to do all of those little things.
So please bear with me for just a moment. I'm going to share my screen again because we have a couple final reminders we'd like to make for you, which hopefully you are now seeing. Here we go. So our next thing is an offline tea break, which will last until 4:30 Eastern time. So that's half an hour. What is coming up next are 3 sessions, 2 which are called cool stuff sessions with 5-minute quick presentations about neat ideas, and 1 that is a poster presentation where you'll be able to look at posters and then go to a different Zoom channel and talk with the presenters about those. Poster presenters, please go to your link. It's in the schedule, your link right now before you go offline. But we'd like everyone else to wait to join the poster session if that's where you want to go. This will let us get the poster presenters in and assigned into the right breakout rooms, and everyone else will be able to join when they would like.
And David, can I make a comment about that? Because I'm going to be managing that. When you enter the poster session, if you could please drop into the chat what room you want to go in. You have to imagine the poster session is a revolving door that lets one person in at a time, because we are going to be manually assigning people into the breakout rooms based on which poster you want to see. So, you know, hopefully after the initial crush, it'll get a little smoother, but it is a one-person job, me. And so please bear with me as we try to get people moved around as fast as possible.
And at the same time, we'll also have these 2 cool stuff sessions. This is all running in parallel. So each of the 3 things you see right here are at different Zoom links. And you can come and go from them, but be sure you know that you're choosing different Zoom links for each of them. And then there is a completely optional, no agenda, happy hour together at 6 o'clock Eastern if you would like to join us tonight. This is just a chance to talk. That's everything from us. Anything else, Sharona?
No, I mean, since we're not going to be back together until tomorrow morning as a big, huge group, I just want to say this has been incredibly impressive, and I've really been enjoying hearing all the conversations and all the panelists. So thank you to everyone who participated today, and we certainly hope that you're going to make it back tomorrow after I mean, we still have more sessions, but not a big one, so.
Right. See you all then being later.
Yes, half an hour. It's supposed to people.